Hi, dear students. This is Dr. Ashok Jadhav from Department of Electronics, DSM College, Parbhani. We have been studying power semiconductor devices. In previous lecture, we have studied the TRIAC, that was the two-terminal device, and it can conduct in both the direction, and it had a fixed breakover voltage, and we don't have any control on that breakover voltage. Today we shall study the TRIAC, three-terminal bidirectional device, and that means it can be fired, it can conduct in both the direction, and we have control on breakover voltage in either direction, whether there is a positive half cycle or negative half cycle. So let us study its construction, its characteristics, its working, and then discuss some application. Okay, let us study TRIAC, power semiconductor device. Here, this is how TRIAC looks. It is a three-terminal device. These three terminals are MT2, MT1, and gate. MT1, MT2, and gate. This is for attaching the heat sink, because when it conducts heavily, heat is generated and therefore it is connected to heat sink. This is the construction of TRIAC. See that this is the MT1, main terminal 1, main terminal 2. From this, if you can see, from if this is a positive, this MT2 is positive, then you'll find that there is a PN. Okay, and current can flow in this direction if gate is made positive. Okay, now if MT1 is positive, then you can say again once again PN, and if negative pulse is applied to this G, then current flows in these directions. This track conduct in both direction, and this gate has control on its firing voltage, you can say. Here also you have shown construction and the symbol of track. The name track is device because of it has three terminal and it is a AC device. It is a triode for AC, and therefore it is called as a track. Its behavior is like this. It works as if there are two SCRs in antiparallel. That this is anode to cathode, one SCR, and this is anode to cathode. They are parallel but antiparallel, and you have communicate. So this structure works like this, and that's why it can be fired in both the direction, right? So we have studied SCR. Major drawback of SCR is that it can conduct in only one direction. Therefore, it has application in rectifiers. But in AC system, if your load is AC and source is AC, we require control over both positive and negative half cycle. And for this purpose, TRIAC is developed. TRIAC is three-terminal bidirectional device. TRIAC is triode for AC. So TRI and AC taken together, that makes TRIAC. This is how its name is generated. Again, we have discussed it is like two SCR connected in antiparallel. It conducts in both direction after triggering. How TRIAC works? During positive half cycle, when MT2 is positive with respect to empty one, we have to apply a positive gate pulse with respect to empty one. So it begins its conduction when gate is applied with positive gate pulse. During negative half cycle, when MT1 is positive with respect to MT2. In that case, we need to apply negative gate pulse with respect to MT1. Thus, in both the direction, we can make track to conduct. And what is interesting is that the breakover voltage of track depends upon gate current. Higher the gate current, lower will be breakover voltage. And that's why this track has lot of application. Just I have taken few samples which can be used in speed control of motor, intensity control of lamp, or if there is heating system, the temperature can be controlled, or in chopper, the output of the chopper can be stabilized. And what is interesting is that the track and DAC and that control circuitry is used to stabilize and to control automatically. This slide shows you characteristic of rack in both the direction. See, this is the 0 point. This is 0 point, and from the 0 to plus V axis, that is a when MT2 is positive, and the current, if any, during this, right? See that the very first characteristic here. The current is very low, only leakage current, and it is only when this MT2 voltage reaches to breakover voltage of track, and after breakover, see that this current suddenly increases and voltage drops. See that voltage from this level to this level suddenly drops, and you get the large current. You can say that it is fired, it is a conducting, but it fires at this voltage, right? And when this Ig0 means when gate current is 0. But now, if you inject a small gate current, say Ig1, and then the characteristics is same except it fires at this voltage, and after firing the characteristic is same. If you increase the gate current to some little higher value, once again track will fire, but this time it will fire at little lower value. And what this indicates, that it fires here, 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 and that depends upon the gate current. And see here, I have given you clue that Ig2 is greater than Ig1 is greater than Ig0, and that's why you have lower and lower firing voltage. This part of the characteristics minus V and minus I means the characteristics of the same track when MT2 is made positive. No, no, sorry, MT1 is made positive with respect to MT2. So it is a like reverse bias, you can say. And again, you can see that this part of the characteristics is quite similar to that of this, where MT2 is positive and this is MT1 is positive. So it conducts in this quadrant also, and it conducts in this quadrant. This is quite symmetric because doping level about PNP region and N deposition is the same from both the direction. So main idea is that you have here AC device, it can be used in AC circuit, and you have control on its firing. Let us consider a simple application. This is a lamp intensity controller using DAC and track. See here, this is a one terminal, the terminal where AC source, VS is the AC source, and this is the lamp that works as a load, and we wish to control the power from this to this lamp. Okay, and how it is controlled from this point to this point? It is track. This is the symbol of track. MT2, MT1, this gate, and this is the symbol of DAC. Suppose this is a DAC of 30 volt. Now see, when their positive cycle occurs, this voltage increases, and from this point we have connected one resistor. Here we have variable potentiometer and a capacitor. So voltage at this point will begin to increase with the this injection of positive half cycle. At a particular voltage, the voltage at this point, if it crosses 32 voltage, the gate, this diac will provide gate triggering pulse, and this track will start conduct. It works as a closed switch, and therefore for the remaining part of that half cycle, current will flow in this direction, and accordingly you will get light intensity. Now when it is a negative half cycle, in that case MT1 becomes positive, and this because of the capacitor, and with respect to this terminal is now at lower voltage than MT1, so negative, and that's why this track begins to conduct in this direction also. So idea is that in positive half cycle and negative half cycle, it can be made to conduct, and by changing this resistance conveniently, you can fire this track at a particular point in this half cycle and this half cycle. So this is a, like you can say, this is a fan regulator. If you have your fan, by varying this potentiometer, the speed of the fan can be changed. Your lamp intensity will change, and see that these two now diac track pack is available in a single IC, and just by connecting one resistance, capacitor, and potentiometer, you get the lamp intensity control or speed motor speed controller of using, of course, diac and tracks. Right. So, dear students, I'm sure you have understood the working of the track, its characteristics, and its application. So, before leaving this lecture, I request you to subscribe, comment, and like my channel. See you next time. Bye.